So this is week 1, day 2 of the pre-algebra presentation. So we'll discuss exponential notation, order of operations, integers, and the number line. So you can see our objectives, and we will begin with a review of the exponential notations and continuing with the order of operations. So remember, anytime we see a number of factors like we see here, 1, 2, 3, 4, I see 5 6's being multiplied together. So how many factors are present? Well, there's 5 of them. Well, what are the factors? The factors are 6. So notice it almost sets up like an exponential notation. You've got 6 as the base, 5 as an exponent. And so the base is 6 and the exponent is 5. Here we've got something already written in exponential form, so notice the base is 3, and those are the numbers that you see. And then how many 3's you see being multiplied is your exponent. So here's where I would just ask you to create an expression that's in exponential notation. So the first one says there's a base of 7 and an exponent of 4. So 7's the larger number, 4 is the smaller number. 4 is represented as the exponent. On the second one here, base of 3, exponent of 5. That just means 3 times 3 times 3 times 3 times 3. This in expanded form just means 7 multiplied 4 times, 3 multiplied 5 times. And the last one, base of 2 raised to the third power, which means 2 times 2 times 2 in an expanded form. So in order of operations, Kirsten runs a website that helps her people learn programming. So in every month, she has a fee of $10 for each of her subscribers. So we'll say 10S. So any of her subscribers per month is going to be multiplied by 10. So last month, the website had 100 subscribers. So we could say, well, last month there was 100 subscribers. This month, 30 new members joined and 10 members canceled. So that was last month. Well, this month, if we retain the 100, but we gain 30 new, but then lose 10. It says that 10 members canceled. So this order of operation looks as if, what would it be this month? Well, there would be $1,000, and here's $300, and lost 10 members at $10 each, so that would be, and so that would be 100. So just go back and left to right, so 100, so 1,000 plus 300 would be 1,300, and we're going to take away 100, so we should get $1,200 is what she made this month online. So that was more contextual order of operations. This one, if we look at the first one, I've got 9 times 5 plus 6 divided by, and in bracket 14 minus, and in parentheses 5 plus 3, close it, bracket, and then the braces are around the 6. So you're looking innermost. So you find these braces and you're looking at, and these are grouping symbols, so you look inside there and you see that number, so that operation. So 5 plus 3. So that's what we're going to do first. And 5 plus 3 is 8. So notice that I'm just simplifying as I go, but I'm also going to just continue to write 14 minus 8 is 6. And then I continue, 6 divided by 6 is 1. And then I'm left to right, so that would be 45 plus 1, 46. The next one would be 16. So 16 divided by 2 plus 40 minus 13 minus 4 times 2. Close off the bracket, close off the braces. So innermost, you're looking right here, so that's 4 times 2. So we'd have 16 divided by 2 plus the brace of 40 minus 13 minus 8. Close everything off. I'm still working inside here. So that'll be 40, take away 5, and that's going to be 35. And so everything inside the grouping symbols has now been simplified. So 16 divided by 2, left to right, division before addition, that's going to be 8 plus 35, which would be 43. And then next we'll look at 10 to the third minus 10 times 6 minus, in parentheses, 4 plus 5 times 6. So we're back to parentheses. I see 4 plus 5 times 6. I got to do the multiplication first. So 5 times 6 is 30. And then you come back in here and finish that off to be 34. And then this is going to be 1,000. 10 to the third is 1,000 minus, next would be the 10 times 6, which would be 60. And so now 1,000 minus 60 would be 940. Take away 34, which would be 906. Then last we've got 2 to the third times 2 to the 8th. Two to the third times 2 to the 8th divided by, what was it divided by? Divided by 2 to the 6th. So left to right. So this is one of those exceptions that we really haven't talked about with exponent rules, but this is what we would use. We'd have 2 to the third times 2 to the 8th would actually be 2 to the 11th. You have 3 2's being multiplied here. You've got 8 2's being multiplied here. So total, you've got 11 2's being multiplied. And then here you've got 6 2's being multiplied. So what would happen is you've got 2 to the 11th divided by 2 to the 6th, which is actually 2 to the 5th, which should be 32. Find your 4's. This is an example that we talked about in class, as you're just trying to figure out different ways that you can create numbers 0 through 30. And you can only use certain operations, but you can use all their operations, but you can only use 4's. So these are just examples of how you would use grouping symbols and different operations to create the answers, at least up to 20 here. Second part is looking with our objectives, integers, order on the number line, and absolute value. So when we talk about introduction to integers and what are integers and where are they on the number line. So integers is this first time we start to discuss where these fall on the number line. And integers do include 0, and they include all the positive numbers and all the negative whole numbers. Okay, so let's stress that. Whole numbers are your integers. We can have 2.5 as an answer. 2.5 is on the number line, but it's a fractional number. It's 2.5. It's 25/10. It's not an integer. We could have -3 1/3, which is a mixed number, but it's not a whole number. So therefore, it's not considered an integer. So, like I said, integers consist of positive, negative, whole numbers, and 0. What are not considered integers? So you think, well, it cannot be a positive whole number. It cannot be a negative whole number. And it cannot be 0. So what you got are any of your fractional answers, decimals, you've got irrational numbers. All of these can be positive and negative. So if you look at that 5/8, -7/9, these are fractional answers. Probably ought to change that to maybe 1/6. Otherwise, it's 0. And 0 is an integer. So if you make them fractional amounts or decimals, now those decimals could be terminating, like 25/100ths, or they could be repeating with the repetin bar. And so those would be considered decimals, which are not integers. And then you've got your square roots. So you've got square root of 3 or 4 square roots of 5 or 2 pi. Any of those would all fall under the not considered an integer. Absolute value we talked about is the idea of distance on the number line. And we want to be thinking positive. So what's the absolute value? Okay, so if I'm looking here and I see absolute value of -2, well, here's 0, there's -2. Well, that distance from 0 here and that distance here, -2 to +2, they're both 2 units away from 0. This is just in the negative direction. This is just in the positive direction. So the absolute value of -2 is 2. The absolute value of 3 is 3. Notice we're talking about distance that is positive. So when we look at the absolute value of -3, we're talking about 3 units away from 0. Absolute value of 5, it's 5 units away. So when we say absolute value of -3, 3 is our answer. What's the absolute value of -29? 29, because remember it's 29 units to the left of 0. -3 is 3 units to the left of 0. 12 would be 12 units to the right of 0, and it's still positive. You can also think of opposites when you're talking about absolute value. The opposite of 3. So when you think number line, if there's 3, the opposite would be -3. What's the opposite of -4? Well, it would be +4. What's the opposite of 5? Well, it would be -5. And the opposite of 0, there is no opposite of 0 because 0 is neither positive nor negative. And then you've got your practice with absolute value in the number line. So I hope this has been helpful. So we've looked at the additional problems with exponential notation using order of operation. We looked at integers, how we can find them on the number line, how to find absolute value, and the opposites of numbers.